We are going to talk about harmonic series and test for divergence. So for the harmonic series is the sum of 1 over n. N goes from 1 to infinity. So we have 1 plus 1 half plus 1/3. So the denominator has an increment of 1. And this harmonic series is always divergent. And then for test of for convergence, if the limit of an does not exist, or if the limit does not equal to 0, then the series of the sum is divergent. So what is that mean? So for a infinite series, right? So we have a sum, n goes from 1 to infinity. An, you have a1 plus a2 plus a3 plus a4, and then we keep on going, right? And then plus an, and then we keep on going. So what we are trying to do is we take the limit. So why do we want to take the limit? Because we want to know as n approaches to infinity, what is the an approaches to. If the an approaches does not exist, so if the an cannot be determined, then the sum is divergent. If the an is not equal to 0, so what do I mean by an is not equal to 0? So an is not equal to 0 means that number is still very, very large. So you are adding up a large number to partial sum, the sum must be convergent. All right, so we have 5 examples in here. Let's go take a look. Determine whether the series is convergent or divergent. If the series is convergent, find the sum. So number 1, we have the sum. N goes from 1 to infinity, 2 plus n divided by 1 minus 2n. So this one we are returning to differential calculus. So we are taking the limit. So this is the limit as n approaches to infinity. We have 2 plus n divided by 1 minus 2n. How do you solve this type of limit? Do you still remember your differential calculus? You have to look at the highest degree in the denominator, which is 1, and then you have to divide the top and bottom by 1 over n. If the highest degree is 2, then we divide it by 1 over square. Then we divide the top and bottom by n square. So, and then we do the math. So this is limit as n approaches to infinity. 2 divided by n, and then n divided by n, 1 divided by n minus 2 divided by n. And then this is limit n approaches to infinity. We have a fraction plus 1, 1 divided by n minus 2. So the fraction, we have infinity. So that means we have 2 divided by infinity is 0. You have to know this from your differential calculus. 2 divided by a very large number is always equals to a 0. All right, but infinity divided by infinity is indeterminate. So we have 0 plus 1, 0 minus 2. So overall, that is equals to negative 1/2. So since the nth term is equals to negative 1/2, so what does that mean? That means this is not equal to 0. So it's not equal to 0. That means we are still adding numbers up. So that's why the series is divergent. We are still adding numbers up, and then by the way, we don't stop at n. We stop at infinity. We do not stop at n. So that's why you look at the n, is still a negative 1/2. So if you keep adding up numbers like that, the sum is going to be the series is going to be divergent. And then number 2. Oh, by the way, if you want this problem, you have to take a screenshot right now. So you don't have to keep rewinding the video back to this position to check the problem. So we have sum, n goes from 1 to infinity, 3n plus 1, and then 4 to the negative n. It looks like we have to do something like a geometric series. So that is the sum, n goes from 1 to infinity. The negative power goes to the denominator, and then this is a 3n, and then times 3. And then we write it like that, n equals to 1, infinity, the 3 stays up here, and then we have 3 over 4 raised to the n of power. So that is the law of exponent. You study that in elementary algebra. The common ratio is 3 over 4. The absolute value of that is less than 1. So that means the series is convergent. Converges to what? So the sum is equals to the first term divided by 1 minus the common ratio. The first term when n is equals to 1, we have 3 times 3 over 4, and then the common ratio is 1 minus 3 over 4, so that is equals to 9 over 4, and then this is a 1 over 4, the sum is equals to 9. So that is the sum. All right. And then in problem 3, change color for every problem. So in problem 3, we have the sum. N goes from 1 to infinity. 1 divided by 4 plus e to the negative n. Looks like we have to work on the negative n power. Sum n goes from 1 to infinity. So that is 4 plus 1 divided by e to the n. And then what happens when n approaches to infinity? So as n approaches to infinity, we have 1 divided by 4 plus 1 over e to the infinity, which is a 0, right? So this fraction is equals to 0. We have 1 over 4 plus 0, then the sum is just equals to 1 over 4. Is that convergent or divergent? We are talking about the an. The nth term is still a 1 over 4. That means we are still adding values to the partial sum. That means the series is divergent. This is by what test? This is by the test for divergence. It is saying that at the nth value, the a to the n, the nth value, you are still adding up real numbers to it. So that means the series is divergence. And then the next one, number 4. Number 4, we have the sum. K goes from 1 to infinity. We have sine of 100 and then raised to the kth power. Looks like a geometric series to me, right? So the common ratio is sine of 100. So this one you can use a degree mode to approximate that. That is around negative 0.506. So the absolute value of r is equals to the absolute value of this. That is less than 1. So that means the series is convergent. And then converges to what? The sum is equal to the first term, which is sine 100 raised to the first power, 1 minus the common ratio. So this one is equals to negative 0.336. This is the sum. Back in the previous problem, the blue one, the 1 over 4 is a term, is the nth term. That is not a sum. This is not a sum. Not a sum at all. That's the nth term. This one, the s, is equals to a sum. All right. So moving on to the last problem, and then we have one more example. So the last problem, number 5, we have the sum, and then n goes from 1 to infinity. We have ln of n squared plus 1 divided by 2n squared plus 1. This one, for the limit, you study that technique as well. So you have to take the limit as n approaches to infinity. Ln n squared plus 1 divided by 2n squared plus 1. What's the highest degree in the denominator? Is 2. Do we care about the numerator? No, we don't care about the numerator at all. And then you have to multiply 1 divided by n squared, 1 divided by n squared. So this one is equals to limit as n approaches to infinity. We have ln, so we have n squared divided by n squared plus 1 divided by n squared. By the way, the n squared in the denominator, they are all the yellow n squared. 2n squared divided by n squared plus 1 divided by n squared. And then we have limit as n approaches to infinity. This is, we have a ln, 1 plus 1 over n squared, and then 2 plus 1 over n squared. So all the fractions become 0. Then we have ln, 1 plus 0 divided by 2 plus 0. So therefore, the nth term is ln 1/2. This is the nth term, an, not a sum, right? Not a sum. So the nth term is not equals to 0. So according to the test for convergence, the series diverge. Alright, so that is the end of this video. If you think my instruction is helpful, please like, subscribe, and share. What do you think? Let me know in the comment section below. I appreciate your help really, really much. I see you all in the next lesson. Signing out.